first video is going to be on squares and square roots. So one question that you might have, well, what is a square? What's a perfect square? For the students, what you should think on is the first activity we did with the Cheez-Its. If you had a Cheez-It and you had 3 Cheez-Its for the length, and we had 3 Cheez-Its going the other way as a way around also, it was a 3 by 3. And that meant that the total area we had 1, 2, 3, 4, 5, 6, 7, 8, 9. There were a total of 9 Cheez-Its. So that had an area of 9. So a 3 by 3 has an area of 9. So 9 is a perfect square because of the fact that both sides are the same length of 3, and that makes a perfect square. So if you had said something and it said it had an area of 25, 25 would go on the inside, and you would ask yourself, well, what are my side lengths that when multiplied together gave me 25? And you should be able to say that your side lengths were 5. Therefore, the square root of 25 is 5. Okay, if you see something that's just like this, there's nothing on the outside of our square root symbol, you read it as, what is the square root of 100? And your answer would be 10, because of the fact that 10 times 10 gives you 100. It's a little bit different if now on the outside it tells you it wants the positive and the negative value of 100. So because it has this symbol on the outside, and your answer, you're going to carry that symbol down and then tell us that it's 10. Because positive 10 times positive 10 gives us 100, and negative 10 times negative 10 also gives us 100. Now sometimes you're going to see it where it wants the negative value for the for the square root of 100. You're going to just drop that value down, and square root of 100 is 10, so you're going to tell us it's negative 10. If no symbols on the outside, it just wants the positive value. If you've got the positive and negative value, you want to bring that symbol down. And if it just wants negative value, just bring that negative symbol down. Now the issue is sometimes when you see a question asking and they want you to tell them what the square root of 65, between which 2 consecutive whole numbers does it lie between? Well, you first need to make sure that you understand what the word consecutive means. Consecutive means one next to the other. So if you have numbers, you don't say 7, 15, 20. No, you would say 7, 8, 9, 10. So 7 and 8 are consecutive, 8 and 9 are consecutive, 9 and 10 are consecutive. So we need to find between which 2 consecutive whole numbers does the square root of 65 lie. So this is when you need to start thinking about your perfect squares, or taking one of your whole numbers and squaring them and seeing what you get. So we can start off a little bit smaller and work our way up. So let's start at 6 squared. 6 squared is 6 times 6, and that's 36. Then we would have 7 squared, which is 7 times 7, and that's 49. So you can ask yourself, does 65 fall between 36 and 49? No, it doesn't, so we have to continue. Then we would have an 8 squared, which is 64. Does 65 fall between 49 and 64? No, it doesn't, so we have to continue on to the next one, which would be 9 squared, and that's 81. Does 65 go between 64 and 81? Yes, it does. Therefore, the 2 consecutive whole numbers that it falls between are 8 and 9. You then would have to go and plot it on a number line. When you plot it on a number line, you only need to give me 4 different points. The 2 numbers that it's in between go in the middle. 1 more than 9 is 10. 1 less than 8 is 7. Because we know that it falls between 8 and 9, we're not sure yet which number it's closer to. So we need to go ahead and mark the halfway point between 8 and 9. So you do a dotted dash. And it's not perfectly even, but we're going to act like it's in the middle. As long as you have that dash, I'm going to know where you think halfway point is. So now we need to determine, well, which one is it closest to? So what I would do right above 8, I would go ahead and plot that 8 squared is 64. So on 8, falls the square root of 64. On 9 falls the square root of 81, and we're trying to find where square root of 65 is closest to. That's why it's between 8 and 9, because it is in between square root of 64 and the square root of 81. To know which number it's closest to, we need to say, well, how many units away is the square root of 65 from the square root of 64, and how many units away is it from the square root of 81? So we take our perfect square, so we take 64, and we take our 81, and we want to find the differences of it with 65. So 65 is larger, so I actually need to have 65 minus 64, and that gives me a value of 1. For 81, it would be 81 minus 65. For that, I would expect y'all to show me your work off to the side. So you can have 81 minus 65. You can't subtract 1 from 5, so we need to borrow and carry. We get 6. We get 1. So that is 16 units of a difference. 1 is smaller. 1 went with the 64. So it is closest to the square root of 64. So anywhere between your 8 and your halfway mark, you can plot the square root of 65. And when you plot it, just don't put 65 because you don't say 8, 65, 9. It is the square root of 65. We're going to do one more example. What if I ask for you to give me the square root of 105? So this is again where we ask for you to start off with some of the perfect squares that you know. And well, I can start higher because I know that 10 squared gives me 100. And so after 10 squared, I would do the next consecutive whole number, which is 11. So 11 squared is 121. And 105 is certainly in between those two numbers. So the two consecutive whole numbers that it falls between is going to be 10 and 11. So let's go ahead and start to plot that. I need 4 points on my number line. My 10 and 11 go in the middle. 1 more than 11 is 12. 1 less than 10 is 9. Because it's in between 10 and 11, I want my halfway mark specified. And right above the 10 is where I can plot the square root of 100. And right above the 11 is where I can plot the square root of 121. And so we need to know between which one is it closer to. Is it going to be closer to square root of 100 or square root of 121? So we need to find some differences. So I'm going to take my perfect squares of 100 and 121 and find the differences. So I'm looking for the square root of 105 minus 100, and that's going to give me a difference of 5. For 121, it's going to be 121 minus 105. I would want work off to the side for that one. So 121 minus 105. Can't do, so we borrow and carry. And that's going to give us a difference of 16. 5 is a smaller number, and that was with 100, and 100 was 10 squared. So it's going to be closer to the square root of 100. So anywhere between the 10 or the square root of 100 and the halfway point is where you can plot that. And make sure you put your radical sign on it, because we're not plotting the point of 105, we're plotting the point of the square root of 105. Okay, so I'm going to go ahead and give you a problem. I want y'all to tell me where, between which two consecutive whole numbers does the square root of 30 lie. I also want you to plot it, and I want you to be able to tell me which number it's closest to. So at this point, go ahead and pause the video and try and solve it. And then when you're done solving it, go ahead and press play and see if you got the answer correct. Okay, so you should have started off with, and you could start as low as you want, but I'm going to start with 5 squared. I know that 5 squared is 5 times 5, which is 25. Then I would do a 6 squared, because after 5 comes 6, and 6 times 6 is 36. And 30 certainly falls between 25 and 36. So we want to plot that with 4 points. And we start with What it's in between in the middle, 1 more than 6 is 7, 1 less than 5 is 4. Give the halfway point as best as you can. Above the 5, we would plot the square root of 25. And above the 6, we would plot the square root of 36. And we need to know square root of 30, is it going to be closer to the square root of 25 or the square root of 36? So we can show that work off to the side. So I want to take my perfect squares of 25 and 36 and find the difference of the square root that I'm looking for. So 30 minus 25, that has a difference of 5. And 36 minus 25 has a difference of 11. You might have shown me your work off to the side for that. That's not required. And so 5 is certainly smaller. Oh, I apologize. When I did 36 minus 25, we were looking for the square root of 30. So 36 minus 30 gives us 6. And 5 is smaller than 6. So we would want it in between the 5 and the halfway point. So that's where the square root of 30 lies. We're going to do one more practice problem just to make sure you have it correct. Okay, how about if you can give me the square root of 115? Between which two numbers does the square root of 115 lie? So go ahead and pause the video. Make sure that you have solved it out, you've plotted it, and you've told me which number it's closest to. So pause the video now and solve it out on your own. Okay, so let's go ahead and work this out. So I'm going to start with 10 squared, which is 10 times 10, and that's 100. Then I'd move on to 11 squared, and that's 11 times 11, which is 121. And 115 does fall between 100 and 121. So we want to go ahead and get the number line started. We plot the two that it's in between up top, and we fill out our other numbers. We want to go ahead and specify our halfway point. Above the 10, well, that was the square root of 100. Above the 11, that was the square root of 121. What we need to see is 100, square root of 115 closer to square root of 100 or closest to square root of 121. So take the two perfect squares that we have, which are 100 and 121, and we want to subtract them with the square root that we're looking for. So 115 minus 100, that gives me a difference of 15. And 121 minus 115, I don't want your work off to the side for this. Can't do, so we borrow and we carry. And it's 0, 0, so that's just a difference of 6. Well, 6 is smaller than 15. 6 went with the 121, and so 121 was 11 squared, so it's going to be between the halfway mark of the halfway and the 11, so anywhere in between there. We're going to plot the point, and then we're going to specify what that point is. And it's not 115, it's the square root of 115. So that's how you do that. In this, it's also not just about square roots, it's also about squaring some numbers. So let's look at 3 squared. This 3 is my base. And the 2 is my power or my exponent. That 2 tells me how many times I'm going to see the number that's directly next to it. So I'm going to see my 3 2 different times, and I multiply them. So 3 times 3 is 9. So let's look at it if we have 4 squared. My power, my exponent is 2. Tells me that I'm going to see what's next to it. I'm going to see that 4 2 times, and I multiply them, and I get 16. What's tricky is when we start getting negatives involved with it. So we're going to take a look at the difference between these two. don't forget, my power, my exponent tells me exactly how many times I'm going to see the number directly next to it. Directly next to it is the 3. And 3 times 3 is 9. However, I want the opposite of 3 squared, or you can say 3 squared negated. So go ahead. So I want the opposite of 3 times 3. 3 times 3 is 9. I want the opposite of that, so I get negative 9. Now let's take a look at our second one. Our exponent, our power, tells us what we're going to see directly next to it. Directly next to it is our parentheses. So you take everything inside of the parentheses. So inside the parentheses is negative 3. So I'm going to see negative 3 2 times, and they're being multiplied. A negative times a negative is a positive, and 3 times 3 is 9. Let's go over that one more time with some different numbers. So if I have it written like this, I'm going to say, well, I see my exponent or my power right here, and directly next to it is the number 4. So basically I'm saying, what is the opposite of 4 squared, or what is 4 squared negated? So the opposite, I'm going to see my 4 2 times. 4 times 4 is 16. I want the opposite of 16. Opposite of a positive is a negative. So the answer is negative 16. Right here, let's take a look at our power, or our exponent of 2. I'm going to square what's directly next to it. Directly next to it is the parentheses. So I will see negative 4 2 times, and I'm multiplying them. Negative times a negative is a positive. I'm going to put a few up here that I want you to go ahead and solve. So I want you to tell me, what are the values for all of these? So go ahead and pause the video, and you go ahead and list out the values yourself, and then play it when you're ready to see if you got it right or not. Okay, so for A, you should have looked at our power, or exponent. Directly next to it is the number 5. So we would have seen 5 written out twice. They're being multiplied. So you would get 25. For B, we still have where the power base is 2. We look directly next to it. Directly next to it is our parentheses. And in parentheses is the number negative 5. We will see negative 5 twice. A negative times a negative is a positive. Therefore, that is also positive 25. When you look at C, take the exponent or power of 2, look directly next to it. Directly next to it is that 5 only. There are no parentheses. You are only looking at the 5. That is what is right next to what's being squared. So you are asking yourself, what is the opposite of 5 times 5? So it is the opposite of 25, which is negative 25. If you just want to go ahead and write out at the point where you know that you're going to take the negative of it and say 5 times 5 is 25 and do like that, I'm okay with that. But you need to understand the process. Because what you are squaring is the 5. You are not squaring negative 5 here. We're going to do one more. Okay, I want you to go ahead and solve for these 3. So pause your video. When you're ready, hit play and check your work. So hit pause now. Okay, so we're going to look directly what's next to what's being squared, which is our 6. So we're going to take the opposite. We're going to see our 6 2 times. So we want the opposite of 36, which is going to give us negative 36. For B, look right next to it, we have the parentheses. So we really will see -7 2 times, and it will be multiplied. And a negative times a negative gives us a positive. So our answer is positive 49. C, I wanted you to see how it can be written this way as well. Look directly next to it. In our parentheses, we just have the value of 8. So really do want 8 times 8, but we're still going to want to take the opposite of that. So we want the opposite of 64, which is -64. So that is what I can show you with squares and square roots. So this video is now done.